G'day. Today's video we're looking at the area between two functions. We looked in the last video at the area between a function and the x-axis. This time we're looking at between when you have two functions written into your examples or your questions. So we've got an example, we've got an explanation up on the board, and I really want to go through so you can see what it means. So if we've got y equals f of x and g of fx, we want to subtract those two away from each other to find that area between. So something similar you did when you do measurements, when you're trying to find the area between two different shapes or composite shapes. Sometimes you subtract them, sometimes you add them. In area between two functions, the general formula is that we'll take the top function and subtract that away, subtract from that the bottom function. So in this case here, we've got f of x, which is that top function, subtracted away from that the g of x. And we have a formula that's written in this term here, where we've got our upper and our lower values here. And another way you can think of writing that is top minus bottom. They don't generally show the brackets in here. I've put the brackets in there because if this function here will generally change. It could change according to what's happening to it, because we're subtracting this entire function away from the original function, or one of your top value. So let's get into an example so you can see how this works. We've got an example over here where we've got y equals x squared minus 2x plus 1 and y equals x plus 1. So we want to find the shade region between these two functions. So let's start off. We start off with 3 and 0, so our upper and lower limits. So it's the top minus the bottom. The top here being x plus 1 minus the bottom, which is x squared minus 2x plus 1. And that's all in respect to dx. Our next step here is we need to make sure we expand this bracket out, so that way we've got a function that we can try and collect terms with it later on. 3, 0, x plus 1 minus x squared plus 2x minus 1, or 2 dx. Now you may think this is something I could start integrating with because I've done that subtraction. However, often when it comes to find the area between two functions, we have to simplify this a little bit further so we get the point that we can't simplify any further to be able to integrate. So we can simplify this by collecting terms. And we would get x plus 2x is 3x minus 1 minus 1 is 0, so minus x squared. And this here is the part that we can start differentiating or integrating. So let's rewrite this up here. 3x minus x squared. Let's start integrating this using our understanding of definite integrals. So open up our brackets. 3x squared over 2 minus x cubed over 3. And that's the boundaries of 3 and 0. Alright, so let's use our understanding of definite integrals to be able to calculate what that actual area is. So we would have 3 over 2 times 3 squared minus 1 over 3 times 3 cubed. Now there's no use doing any zeros because the 0 is going to be 0 no matter what. So we only have to worry about this first function. So let's see, we've got 1/2 times 9. So that's going to give me 4.5 because these two will cancel it. So I would get 4.5 all 9/2 units squared. So really important, now that we're working with functions, an area that we put this unit squared at the end. When definite integrals, when we were calculating, we didn't have to do that, but with applications, we now have to make sure we put in those unit squares. So let's look at a second example, and we'll look at it in the next video, where it's a little bit different to what's happening in terms of this formula, but we're still working the area underneath the curve. See that?